All right, we're now going to continue on with numbers 11 and 12. And so for number 11, we have iron oxide reacting with carbon monoxide to form iron and CO2. And so we're going to start off by counting who we have on each side. So we've got iron, we've got oxygen, we've got carbon on both sides. So on our reactant side, we've got right here, we've got 2 iron. And then we've got 3 iron here and 1 there. Or three oxygen here and 1 oxygen there. So that's 4. And then 1 carbon. And then for the product side, we've got 1 iron right here. We've got 2 oxygen and 1 carbon. So 2 oxygen, 1 carbon. Okay. So first thing I'm going to try to do is I'm going to, since we have half as many iron on our product side, I'm going to see what happens when I change this to 2 iron, and that just changes this 1 to a 2. Now it's looking like our irons are balanced with each other. Awesome. Now I'm going to try to balance the oxygen, and we have half as many oxygen on our product side than our reactants. So I'm going to put another 2 right there in front of our CO2. So that is going to change. Our carbon is now 2 on this side, and our oxygen is now 4. What did I do wrong? Oh, I see what I did wrong. Okay. I didn't do anything wrong. But because now the issue is that we have twice as many carbon on our product side than on our reactant side. But if we add, we can try seeing what happens if we add 2 in front of the carbon monoxide. And what is going to happen is that changes, again, both our carbon and our oxygen. So now while our carbons are balanced, our oxygen, we are going to have 3 here plus 2 here, which is 5. And there's not a quick and easy way that we can mend this or get it balanced when we have 4 over here and 5 over here. So I'm just going to see what happens when I change, like our iron's good, but I'm going to change the numbers in front of our carbons and oxygens to see what happens when I make them a 3 instead, to see if that will give us some balance. And so now on the reactant side, we have 3 carbon, which is looking good. And then we have 3 oxygen in the iron oxide, and then 3 from the carbon monoxide. So that's going to be 6 oxygen. And then on the product side, we have 3 carbon, and then 3 times 2 will be 6 oxygen. Now our equation is balanced. Okay, moving on to our last one, this combustion reaction where we are combusting, I think this is butane. And so again, we've got C, we've got H, and we've got O. C, H, O on both sides. Those are the only elements that we are dealing with. And so starting to count them up, we've got 4 carbons on the reactant side, 10 oxygens, and 10 hydrogens. I don't know why I keep saying that, 10 hydrogens and 2 oxygen. And then on the product side, we have 1 carbon, we have 2 hydrogen, and then we have 3 oxygen. So first things first, I'm going to do, or whenever I usually see combustion reactions, is I'm going to try to balance the carbons and hydrogens first, and then see at the end if there's an easy way to balance the oxygens after the carbons and hydrogens are already balanced. So I'm going to start off, we have 5 times as many hydrogens in our reactants than in our products. So I'm going to add a 5 right there, which is going to turn our, come on, let me click. Now our hydrogens are 10 on this side, and then in our products, we have 5 oxygen with the water, and then 2 more in the CO2, so that's going to be 7. Now to do our carbon, we have 4 carbon over here to start with, and we end up with 1. So I'm going to try to see what happens when I make 4, my coefficient there. And so now, okay, it doesn't like when I do the touchscreen on that one. Now I'm going to count up and I see 4 carbon, awesome, and then I see 4 times 2 oxygen here, so that's 8 plus 5 is then going to give us 13. And when I look over at this oxygen now, so now our carbons and our hydrogens are balanced, but looking over the oxygen, we have a lot less on our reactant side than our products. And there is no whole number that we can put in front of this oxygen that is going to turn it into 13, because 13 is an odd number. And so whenever I see something like that, what I do is I go back and I double all of the other coefficients. And so this was a 1 is now a 2. This was a 4, it's now an 8. And then this was a 5. It is now a 10. Okay, back to my weird clicking. I don't know why the touchscreen isn't letting me work. And then, so now I'm just gonna go through and I'm gonna count up everything and see if we can get a nicer number to balance the oxygens right now. So carbon on the reactant side, we now have, come on, hello, I ruined it. Okay, that's an 8. On this side, we've got 2 times 10, which is going to be 20 hydrogen. And then oxygen, still 2 for now, because we're looking for what that coefficient is going to be. On the product side, we have 8 carbons. Oh my gosh. We are going to have 20 hydrogens, 10 times 2 right there. And then our oxygens, we are going to have 8 times 2, which is going to be 16 plus, oh my goodness, 10 times, or 10 oxygens. And so 10, that's going to give us 26. Oh my goodness, that's a 6. 26. And so now I know that if I need the total number of oxygens on a reactant side to be 26, the number that I have to put in front here is a 13. And that will change this now to be 26. Now we are good and we are balanced. We have 8 carbons on each side, 20 hydrogens, and 26 oxygens. Where'd my mouse go? I need to turn the video.